We've seen the 5 key questions, but we're going to go over them again. And I've said this before, the 5 key questions are not written in stone. You don't have to do them. You have to communicate, but you don't have to do it this way. They don't have to be done in this order. You could go to some other schools in our district or in the province or in the country or the world, and they would have no idea what you're talking about if you said the 5 key questions. But it's a really, to me, nice, succinct way. It's the easiest way to graph trig functions, and it's really succinct, and it just helps us be focused and not get lost in the mix of like, where do I start and where do I go from there? So it just gives you sort of a process to follow. And if you follow the 5 key questions, I'll know what you're talking about. Like if you follow them more or less in this order, I'll be able to follow your work easily. So it's kind of nice for that. Okay. So what is the zero line? What is the amplitude and the max and the min? You need the zero line and the amplitude to get the max and the min, so that's why they kind of go together. And then where does it start? What's the period? Where do it end? So that's like, those obviously go together as well. You need the period and the start to figure out where it ends. Where do it ends? I don't know. Now work out a proper x scale, and as I said, this is a hard part, so I'm just going to write down a little bit here of how you would find the x scale, and we're going to write this out and explain it so you can refer back to it, because it can be tricky. And it can be one of those things where you look back and you're like, where did that number come from? So if you copy it out now, then that might help. So here's what we do. We do, I call it CP. It's the critical points. And this is the period. So you've already found the period, and you divide it by 4. Okay, and what that is giving us is the distance between critical points. And then we take the phase shift. And I'm going to do an example here. This is just a made-up example. So the numbers would come from the question. I'm just going to make them up to talk through this because it can be really important. Okay, so let's say the period is pi. So you divide it by 4. And and your critical points number is pi by 4. What is pi by 4 in degrees? 45, thank you. If you're ever stuck and you're like, okay, I'm confusing myself, in your head, not on paper, but in your head, convert it to degrees and think about it in degrees. It'll make more sense. But then go back and think about it in radians again to make sure you can do there, because you're better off if you can do it in radians, but it can be trickier. What if my phase shift is pi by 6? What do you think about that? What is pi by 6 in degrees? 30. I need, so hear me out here. This is the important part that you have to understand. You may not fully understand it right now. You go tonight, you think about it. If you have to watch the video to hear this discussion again, do that. It might take a few times. My first point will happen, because that's the phase shift, at pi by 6, which is 30 degrees. Every other point will occur 45 degrees, pi by 4, from there. Every one of those points, I'm going to draw this out, has to fall on lattice points or lattice lines or grid lines. So if I'm doing sine and it looks like this, where are those points? 1, 2, 3, 4, 5. Those are the 5 critical points that must be where grid lines meet. for full marks. Okay? So if this is shifted, this one's got to shift. So my first point will be at 30 degrees pi by 6. It won't be at 0. That point will be shifted. And then my next point will be 45 degrees from there. So what if I made my scale, because this would be easy, what if I made my scale 30? So my x scale is counting by 30s. 30, 60, 90, 120. What's going to happen?
You're not going to hit 40 or pi by 4 every time.
Right. So it, like, if I start at 30, the next one is going to be 30 plus 45, 75. Well, 75 wasn't on that scale, counting by 30s. Not going to work. What if I counted by 45s? That would be useful because then every 45 would certainly be a point. Well, hold on. I didn't ask any questions. What if I count by 45s? Yeah, 30 is not going to be on there. You're going to go 45, 90, right? 135, 180. Like, none of the points are going to be on there probably. So we have to, your scale has to match those two values. And it's easy to see when it's in degrees. That if I was counting by 15s, I go 0, 15, 30, 30, right? And then from 30, I'm going 15, 15, 15 to get 45, which is going to be, from 30 is going to be 45, 60, 75. So I'm going to be good. Because 15 is what? Common factor of both of those numbers. It's easier in degrees, isn't it? How do we do it in radians? It's actually also quite easy. What I do is I take these two values, pi by 4 and pi by 6, and we are actually going to write them off to the side. And I say, what is the lowest common multiple between 4 and 6? Max? 12. So pi by 12, you're still kind of asking the question. You're not quite finished. We're not sure that's right. But pi by 12, what is pi by 12 in degrees? 15. That's the same one we came up with. The only thing you have to do from there is you have to make sure that's going to give you a nice graph. If your graph is like going to be this small because it's all crunched into like 4 squares, not okay. Okay, so you're going to have to go, you'd go to maybe pi by 24 to stretch your graph out more. Your graph has to fit most of the grid. Okay? Not the whole grid. It doesn't have to take up the entire page, but it can't be like this, and your 5 points can't go off the grid. So in some cases, you might decide to try to do pi by 24, but your last point doesn't fit. Nuh-uh, no good. That's our goal. All 5 points fit. They're not all crunched together. You know, you'll see as we go through this, you're actually going to do this thing where you think about that 45 degrees between my points. I want that to be about 3 squares, 4 squares, 5 squares, 6 squares, something along those lines. And you're actually going to think about how many squares am I counting. That's what I think is a nice way to do it. Okay? Okay. Any questions about that so far? We're going to do 3 examples. So you're going to see it in action 3 times. Let's get started. This one's actually pretty straightforward because it's sort of a simpler example. So it's not going to show us all of the hard parts in that first example, but it gets us started. So if I do the 5 key questions, I'm going to write them out sort of in full once, but then we wouldn't ever do that again. Question number 1 is the 0 line, because it's just a waste of time. This is not a formal process. This is just us doing the work that's needed, and it is absolutely 100% like strong recommendation that you show some work. If your graph is if you show no work, your graph is perfect, your scale is easy to read, everything's perfect, you're probably going to get away with it, but I really don't recommend that. Show some work so you get part marks at least if you make a mistake. Okay? And it'll be easier for you to go back and check what you did. Check your math, make sure it's right. Like there's all kinds of reasons why it's a good idea to show something. The 0 line, what is the 0 line in this case?
0.
How did you get that?
Because there's no d value.
So the d value would be right here, plus d, but it's plus 0. So you're absolutely correct. the zero line is y equals 0. Comes from the d value. You got to know where they come from. Question number 2 is amplitude. What's the amplitude? Tyler? 2/3. Where'd you get that? I hope it's obvious, but it's the a value, and it's that number right there, right? 2/3. It's not the other number reciprocal or anything weird like that. It's the number out front, so it's 2/3. And this is why I have to do it in this order, is then I can do the max and the min. And again, look at how this is a really informal, like there's no formal notation here. This isn't a thing, but this is just how we do it. So from the 0 line up the amplitude to positive 2/3, and then back to the 0 line, down the amplitude to negative 2/3. What is the start? Oops, question 3. What is the start? Where'd you get that?
There's no C value.
The C value would be in here, inside this bracket with the X added or subtracted. There isn't one, so it's +0 or -0. So that makes the period easy. Actually, no, sorry. That makes the stop easy. We got to do the period. How do we do the period? Isaac? It's related to 3/2. That's my K value. Thank you very much. I'm going to need that. What do I do with it? Isabel? Very nice. 2 pi divided by 3/2. Again, I'm going to show you this sort of like a couple of times, but in general, you don't need to write all this out. And the better you can do this kind of math in your head and follow it, the better off you're going to be in this course, 100%. Okay, so that works out to 2 pi over 1 times 2/3. So that's 4 pi over 3 is my period. And then 5, the stop. The stop is easy because it's the start plus the period. So it's 0 plus 4 pi by 3, which is just 4 pi by 3. Some of this is messy. Some of this is dirty. It's not fun. There's no elegant way of doing it. You got to get your hands dirty and do some fraction math. Whether you can do that in your head or you can use fraction rules or you learn how to do it on your calculator. And if you do that, that's fine. If that's what you have to do to survive, and I'll even help you figure out how to use your calculator for fractions if that's what you need to do. But you need to figure out a way to do it, be successful with it, practice it enough that you've got it. Okay? There's no shortcuts. There's no easier way. Isn't that funny how people, isn't there an easier way? Don't you think if there was an easier way, we'd show you the easier way? Like, what are we out to get you? Those teachers trying to make everything hard. Okay. Those are the 5 key questions. Take the A, the K, the C, and the D and turn it into properties of the graph so that we need to graph our function. Take a look at our function, sine, because we're doing sine here. This second critical point occurs at the maximum. That's why I need the maximum value, so I know where it occurs. This point occurs at the minimum, so I need the minimum value. And the other 3 occur on the 0 line, so I need the 0 line. Like I need these properties in order to come up with, to figure out where those 5 points are, and I need some of the other properties to figure out how to come up with the next scale. So that's what we're going to do next, x scale. So the first thing I'm going to do is the critical points. And that's the period. Some people get confused and they use the stop where it ends. Whoops. You're going to make mistakes doing that, right? In this case, it would work because they're the same, but that's because there's no phase shift, which doesn't usually happen. So make sure you're using the period, 4 pi over 3, and you divide it by 4. So this is 4 pi over 3 times 1 over 4. You want this to be reduced, absolutely 100%. So however you have to do that, works out to pi by 3. I take pi by 3, and I take my phase shift 0, and I ask, how do they go together? See, some people might be like, where did those numbers come from? Why did he take those from there and write them down there? So the arrows, you don't need to write the arrows, but like just to explain, if you're looking back at your notes later or my notes later, that's where they came from. Now it's easy because it's 0. Put your pencil down and watch. If I chose pi by 3, that's the distance between my critical points. I'd be like there, 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 there. That's not okay. That's too squished. This is what I would do. I'd be like, space. Look at all this empty space that you didn't use. Why not? It'll make your graph easier to read, makes it look nicer, makes it easier to use, which is the whole point. Okay? So we want to stretch it out. So how do I stretch that out? What is that number, pi by 3?
The distance between the points.
Yes, and what is it in degrees? 60. What would be nice? What would be a nice number to use to sort of stretch it out? What is pi by 6? 30. So that's going to give me 2 squares. Can we stretch it out even more? Pi by 12. So that's going to give me 4 squares, because what's pi by 12? It's 15. So 4 squares. Notice what you're doing here. That's like if I take the 3 and multiply it by 4, that turns it to pi by 12, which is like dividing by 4. It is dividing by 4. Okay, 60 to 15 dividing by 4. What's another one that we could use? Pi by 9. That would be, if we chose pi by 9, I divided pi by 3 by 3. So the distance, like Lucas said, the distance between my critical points, I turned it into 3 squares. Because I divided it by 3. Pi by 9 would be 20 degrees. 20, 40, 60. The distance between my critical points, and I divided it into 3. So let's count by pi by 9s. It's a little bit of a strange one to do. Pi by 12 would be great. I believe it would fit on this grid. We'll just do pi by 9s. Either would, I think, would be awesome. Go ahead and make your grid. There's no shift up or down. There's no shift left or right, so a grid lines like this would work. You got to make sure you draw your grid lines properly so your critical points all fit. Yep.
We only have to label the points which are like where the.
I'm going to get to that.
We could also use pi by 12, right?
Yes.
That would be right.
Yep. Yep. It's not so much about right and wrong. If your graph is correct and it's not too squished or the points don't go off, then whatever you use is fine. Yeah. Just because you use something different from me or different from somebody else, that doesn't matter. Don't use like pi by 10.25 or something weird like that. Like don't do that, but okay. Okay, now I'm going to do my y-scale first. What was our amplitude? I've got to look at our amplitude for the y-scale. It was 2/3. So how do I make sure my points fall on that? I take 1 and break it up into thirds. So I'm going to go 1, 2, 3 is 1, and 1, 2, 3 is -1. So that 2/3 and 1/3 and stuff fits on that scale, right? That's usually not too hard to do. Now watch this. We did we were doing pi by 9s, but really what I want is pi by 3 is 3 squares. So I'm going to go 1, 2, 3 is 1 pi by 3. Right? 3 more squares is 2 pi by 3. 3 more squares is 3 pi by 3, which is? Somebody said that? Pi, very good. And that's what you want to label. Don't label it as 3 pi by 3. And then 1, 2, 3 squares is 4 pi by 3. And 4 pi by 3 is where it ends. Your scale, has to go up to or past your last critical point. And folks, Lucas, I think this was your question. Your scale should not, like if my first point was here, and then I was going 3 squares, you shouldn't be labeling those. You shouldn't label this point, and then the 3 squares later, and then 3 squares later. Your scale should count by the same number every time, like a normal scale that you learn about in grade 9. Does that make sense? Like you wouldn't count your scale 1, 3, 5, 7. You know what I mean? You'd go 2, 4, 6, 8, 10, and then you'd plot your points between them.
Yeah. I was just, we don't have to like write down the numbers.
Gosh, no. Yeah.
And on the y scale, could we just do on the second one, do 2 over 3 and then 4 over 3 on like one that 2 lower? Like just write 2 over 3 on.
I suppose you could do that. We usually do whole numbers, but as long as it's clear, I mean, you wouldn't lose marks for something like that. Okay, now the last thing we have to do is double check 2 things, at least 2 things. Make sure we haven't missed anything. We're going to look for a reflection, none here, and we're going to make sure that we're graphing the right one because sometimes people get carried away and they just graph sine when it's supposed to be cosine. So we're graphing sine, and there's no reflection. Sine starts at the start and on the 0 line. And then 1, 2, 3 squares, because that's what we chose, to the max. 1, 2, 3 squares back to the 0 line. 1, 2, 3 squares to the min. 1, 2, 3 squares back to the 0 line. Do not use a ruler ever to draw curves. This is not a smooth curve. You don't have to be an artist, but you have to try, and you have to try to improve if you're not very good at it. And it even usually takes me some time at the beginning of the year to warm up a little bit and get better at drawing curves. We do a lot of curve drawing in this course, and if you're taking calculus, there's even more, so you want to get good at it. You are also not allowed to do this, folks. Oh my goodness, no hairy lines where you're like shading it in like this. Don't do that. Learn to draw a smooth curve. You'll get better at it, okay? I know it's hard. I used to hate it. I eventually got good at it. I always shoot for just before the point and then curve it at the end, right? Straight through that one, shoot before the point, curve it, and then straight. Whoop, that was bad. Curve and straight. There we go. It's really hard to do on a computer screen too. It's really different because you don't get that same like friction as you do with a pencil or a pen on paper. It's a lot harder. So it takes me some time to get used to it at the beginning of every semester. All right, on the back of your page, let's do another one. We don't have a ton of time, so we're going to try to get through these. I really hope that by now you're starting to get better at the like the amplitude and that kind of stuff. So we're gonna push through that. But if you have questions, ask them. It's the scale that I'm most concerned about. What is the amplitude? So question number 1. Oh, sorry. What is the 0 line? Question number 1. Yeah. 1, y equals 1, right? So we write it as an equation. Very good. Y equals 1. What is the amplitude? Amplitude is always positive, so it's 2. Very good, but we want to make a mental note that there's a negative there. That's telling us about a reflection. So the amplitude is 2. So the max, folks, watch, and the min from the 0 line, which is 1 up to 3, and from the 0 line down to -1 is our max and our min. So our scale has to go all the way up to 3 and all the way down to -1. The start what were you thinking? Negative pi, not quite. Isabella? Pi over 3. So there's a comment here, don't we have to factor it? Why would it be pi over 3? That's exactly right. Very good, both of you. Anybody else who noticed that? We have to factor that inside part. Be very careful. It doesn't come up a lot, but it catches you by surprise when it does. So I have to pull the 3 out because this is how it's written. Pi by 3. But Adam, it is negative. Good on you for that. Very nice. Okay, so the start is negative pi by 3. The period
This thing 2 pi over 3.
is 2 pi, and I divide it by the k value, which is 3, right? So that came from here, the k value that has been factored out now. And then the stop is the start plus the period. So negative 1 pi by 3, and then I go 1 pi by 3, 2 pi by 3, takes me to positive 1 pi by 3. So the stop is positive pi by 3. Yeah?
So the k value is 3.
Yes. And the k value doesn't change when you factor.
Yeah.
It's the c value that we're worried about.
So how often would it like be like that, like right up against the x?
Out of, you have 6 to do for practice for like homework tonight, and there's none. But I think there's a worksheet later on that has one. Test may or may not have it. I don't know. It comes up once in a while. It's just something you do have to look for. Any other questions? What do we do next? Critical points. So I've got a phase shift, and I've got a period that's a little bit different here. So I've got some work to do. What is the period in degrees, by the way?
360.
How'd you get that? Oh, the general period. I mean the one we're working with. How'd you get that? Okay, good. Or pi by 3 is 60, and you have 2 of them, so 120. Okay, nice. So my critical points, I take the period. Don't take the stop. Take the period. 2 pi by 3. And I divide it by 4. Or multiply by a 4th. And I'm going to do this because we want this fully reduced for sure. And I take my phase shift, and the phase shift being pi by 3 or negative pi by 3 doesn't really matter, right? But it is negative pi by 3. And I think about a common multiple of the 6 and the 3.
I had pi over 24.
Okay, why'd you pick that?
From the last one, you said 4 points, so I just multiplied the.
I like that idea. What is the lowest common multiple between 6 and 3? Bang? Pi by 12, or even pi by 6. Like 6 is actually the lowest common multiple, isn't it? But again, you wouldn't want to do that because then you'd be like 1 point, next point, next point, next point. It would all be squished in. Terrible idea. This is the distance between critical values, between critical points. So your x scale can't be that. So pi by 12 would be 2 of these to make it up. Let's stretch it out even more to pi by 24 would be 4 squares, or pi by 18 would be 3 squares. Either of those, again, is fine. I'm going to do pi by 18. It's a little unconventional, but I kind of like seeing different things come up and working with them. It challenges us a little bit. It pushes us a little bit. Okay, once again, I have to be mindful of I'm going to do my vertical scale first. And I'm going to count, I'm going to stretch it a little bit because I think this will work. I'm going to say this is 1, so I'm counting by halves. This is 2, and I just have to make sure that my max and my min fit. This is 3, which is my max, and this is negative 1, which is my min, so I'm fine. And I'm using up the graph. You don't have to do that. If you counted by ones, it wouldn't be wrong. If you drew your x axis in the middle of the grid, if you're one of those people who just always draws your axes right in the middle of the grid, then that's not going to work for this one, right? If you do the same scale. Okay, so we said pi by 18, or we said pi by 6 is 3 squares. So I go 1, 2, 3 to negative excuse me, pi by 6. What's wrong?
It's just like our greatest modulus, we just changed our scale, so it'll be the same as yours.
Okay. I put my, are you sure? I put mine like 3 from the bottom.
Yeah, and then we don't have enough to go up to 3. Like,
That surprises me.
small.
Oh, yeah, you're right, it is.
Yeah.
I wonder how that happened.
I had 2 at the bottom. 2 at the bottom and then 6 at the top.
Right. Oh, and then it just barely fits?
Actually, never mind. I
Okay. So pi by 6, 1, 2, 3, 2 pi by 6. What is 2 pi by 6? Pi by 3. And that was our start, negative pi by 3. 1, 2, 3, pi by 6. 1, 2, 3, positive pi by 3. If this looks like magic to you, if you thought you kind of got it at first, but now you're starting to be like, oh, I'm falling behind a little bit. I mean, that's fine. Like, you're not going to follow everything that we do necessarily. When you go and practice and then ask questions, but ask, like come back and ask, where did that come from? Okay? You can ask now or you can ask later, but make sure you ask. Okay, I think we got our scale. I think we have all the information we need. We can go ahead and graph. What do I have to consider when I graph? Sure. Very nice that there's a reflection. Which one are we graphing? Cosine. So cosine usually, I'm going to sketch it over here. Cosine usually starts at the max, goes through the 0 line, goes to the min, and goes back to the max. There's my 5 values. Usually starts at the max, but there's a reflection, so we're going to start at the min. And the start is negative pi by 3, and the min is negative 1, so it's right there on that number that I've drawn, but there we go. 3 squares to the 0 line. 3 squares to the max. 3 squares to the 0 line. 3 squares to the min. It is so easy to graph if you understand how many squares you're counting between critical points. And I love that when I graph and my last point, look where it fell, I do a check. Was that my stop, pi by 3? It was. So I must be doing something right. I don't know that I would ever see somebody mess up their scale and still stop where it's supposed to stop. You know what I mean? So that's like a solid check that you're doing it correctly. Any questions? Okay, so here's what I'm going to say. I want you to start the next one. At least get all the pre-work done, and you can try to do the scale if you think you can do it, or we'll do the scale together, but do as much as you can. what I'm seeing. All right, let's see if you got what I got. If you didn't, you can copy it down. That's fine. We still have 10 minutes, which is enough time, so that's great. I don't want to take too long because I do want to talk about this. This one's quite a bit trickier, but it maybe is the one where the scale finally starts to click for some people. So let's see if you got the same thing that I got. And what I got was, well, everybody got this part right. The zero line is just -1. It's that number out there. Amplitude is 1/3. And then from -1 up 1/3 to -2/3, right? Again, counting in fractions. 0/3, 1/3, 2/3, 3/3, which is -1. So up from there to -2/3, and then down from there to -4/3. The max and the min. The start is pi by 2 because it's x minus pi by 2, so that's a shift to the right by pi by 2. And my period is 2 pi divided by 2 over 3. And I showed a little bit of work here on how I got it to 3 pi. And then look what I did for the stop. I did 1 pi by 2 plus 6 pi by 2. What's 6 pi by 2? 3 pi, right? Common denominator, you need to add them. So that adds up to 7 pi by 2. 7 pi by 2 is not a very useful number, but it's going to be a nice check later on. Is everybody okay up to there? Critical points. X scale, sorry, I should say. X scale. Critical points are the period, not the stop, the period divided by 4. So that's just 3 pi over 4. And my phase shift is pi by 2. What is the lowest? Just tell me straight out. Don't pick a number. I don't want you to pick what you think is the right number. I want you to tell me what the lowest common multiple between 2 and 4, my denominators, is. Sam? 4 is, so pi by 4. Right. So I'm going to write that down. And I want you to think about this, because this question is a bit different from the last two that we did. When we look at pi by 4, what do we think about that? How do we feel about that? That's the lowest common multiple between the two denominators. But what does it mean in the context of an X scale? What do you think?
Every 3 there'll be a group.
Every 3? What do you mean?
Because it's 3 times the...
3 pi by 4. It's all the other ones were like 1 pi over. This one's 3 pi over, so it's a little bit different. What is 3 pi by 4 in degrees? 3 pi by 4. 135, what's pi by 4? 45, a third of that. So it'll take 3 of them to get there. Do you see that? I see a few people nodding and they're getting that. Do you see that? So this one will work. So see what I mean? You got to think about, like, you got to kind of think about how many squares is this going to be. And what's pi by 2? 90. So 45 will fit. If I count by 45s, 45, 90, 135, 180, it's going to work. It's tricky. I hope you followed it a little bit. And now I'm going to say, like, you go and try a few and try to go through that process of the lowest common multiple and think about counting squares, how many squares, and think about the fractions. If you have to, turn it into degrees because it's a lot easier in degrees. If the distance between my critical values or critical points is 135 and I start at 90, counting by 45s will work. So pi by 4 is good, and I'm going to use that one. And again, I'm going to do I've got to break my scale up into thirds because of the 2/3 and the 4/3. So 1, 2, 3 to -1, and 1, 2, 3 to -2. And 1, 2, 3 is 3 pi by 4. 1, 2, 3. You could count by pi's. You could go to the fourth one and just count, like 4 squares would be pi. If you want to do that for your scale, you can do that. It's the same scale, but you're labeling it differently, right? But if you like that better, that's fine. We're doing it this way. We're going to go 3 pi by 4. 6 pi by 4, what's that? What's 6 pi by 4? Okay, good. 3 pi by 2. So 7, 8, 9 pi by 4. 10, 11, 12 pi by 4. What's that? Thank you. 13, 14, 15 pi by 4. And that takes us, that I think is going to be far enough. Are you starting to see why from the beginning of all this I told you it helps to count in like fractions and get to understand radians and fractions a bit better, because we start doing this and it's quite tricky. Question?
Is there supposed to be 3 space in the beginning?
Yeah.
I thought it's only 2 pi, you'd only start 2 squares instead of 3.
Where we're going to plot our point is different from where we label our scale. So give me a second, and I think it'll clear itself up. Okay, put your pencil down and watch. I think you'll be able to copy this down after. No reflection, and I'm graphing sine. Sine starts on the 0 line. The 0 line was -1, and it starts at pi by 2. 1 pi by 4, 2 pi by 4 is pi by 2. So my first point goes here. Am I right?
Oh, okay. Okay, I just didn't know if it was going to land on that.
1, 2, 3 squares to my next point. 1, 2, 3 squares, which is at the max, to my next point on the 0 line. 1, 2, 3 squares to the minimum. 1, 2, 3 squares back to the 0 line. And what is this value? This is 15 pi by 4, so this is 14 pi by 4, which is max? 7 pi by 2, which is exactly where we wanted to end. It's a check, but I know it takes some practice with fractions.
See what I was talking about earlier? I thought you wanted us to label.
No, I want a proper scale that's drawn properly. That's what I was trying to say. But now it's more obvious because we did an example of it. You do not start your scale 2 squares from the x-axis, then start labeling every 3 squares or every 5 squares or something. No. You label it from the x-axis. This is just a formality, but from the x-axis, you label it the same distance all the way. And if your points fall between that, again, that challenges us a little bit more. It's a little bit harder that way, I think.
Like if you want to, you could do like pi, 2 pi.
Yeah. I wouldn't label every 1 because it's going to bunk it up too much, and I wouldn't even label every 2 because I think that's maybe too much, too crowded. But every 3, every 4, every 5, yeah, depending on your scale and how it works. Okay, I'm going to hand out the worksheet.